Welcome back, fellas. Today we will be doing some offensive security practice, and in this regard, we will do the TryHackMe lookup room, which is a typical boot to root machine. So what are we waiting for? Let's get started.
So as with any engagement in the offensive domain, we start with the Nmap Scan. So this is the command that I chose. So here, I scanned for all the services to expose the version of each service, and I use aggressive scanning because I know beforehand that this target machine is used for testing scenarios. It's not a real production machine. If it was a real production machine, I would not have used the -A, simply because the production machine, assumingly or supposedly, is behind firewalls. And if you use -A, you will trigger firewalls. That's why it's only recommended to use -A or any aggressive scanning mode only against CTF machines or demo machines. Okay, so when we do the scan, as you can see, we have two open ports, 22 for SSH and 80 for HTTP. As we don't have any credentials, we're going to skip the SSH for now and start the enumeration with the web server on port 80. Okay, don't forget to add the lookup THM to your host file. If you do not do that, it's a bit much obvious. Just nano the host file at this location and add these two entries. For now, add this entry only, the IP address, okay, of the machine along with its name. Once you do that, when you attempt to access the page, you will be actually prompted with the login form. So here, a login form with the username and password. Now, we could have some assumptions, or we could have some default credentials to try with, such as admin. Let's try with that. Wrong password, please try again. And it has redirected me to the main, or back to the main page. If you want to play with this, you want to send this to Burp suite. So I've already done this. I inserted the request and send it to the repeater. Now in the repeater, here we have the request and the response. So basically, that's the request I sent a while ago with the username admin and the password admin. And on the response, there is the response, the statement, wrong password, please try again. So indicating that the username is actually correct, but the password is wrong. Now here, we're not given any hint about the valid usernames to try with. So you might want to approach this using two methods. The first method, you might want to use Burp suite to brute force both usernames and passwords. So you might have prepared some word list here, using maybe sec lists or using, so the word list I have here, we have RockU, we have sec list master. So we could try these word lists, okay, and brute force the usernames and the passwords. But this will go actually a long way in determining what are the valid usernames and passwords. So to minimize the wasted time, we can create a Python script that first start enumerating the valid usernames. And we can actually rely on the response provided by the application to determine whether the supplied username through the word list is valid or not. All right, let's try with another username here. Let's try with maybe test, and the password is test. Sending this will give us a different response. Here, the response is wrong username or password. Please try again, redirecting in 3 seconds. So here, both the username and password are wrong. In the previous request, the username was correct, however, the password was wrong. So we will be relying, or we will be using the output here of the application and supply it to the script that we will be creating in order to help determine whether the username that we are actually going to use through our word list is valid or not. Let's have a look at the Python script here. So this is the Python script. Let's go over the script here. First thing, we import requests because we want to handle HTTP requests, and we define a variable named target underscore URL. The target URL equals to the path to the login page, okay? And then we define the username dictionary file, or the word list for the username. Basically here we are only brute forcing valid usernames. That's the first step. So here the path to the word list. It's up to you to choose what the word list, but seclist has a dedicated word list for usernames and contains actual names, actual real names. So you could actually use this. And then we have a try loop. So in the try loop here, we have also for loops. In the for loop, we loop through the username file and we actually format it so that we strip the lines and we skip empty ones. And then in this line, we construct the pair with the fixed password. So the username here will be derived from the word list, and we'll be using a fixed value for the password. The password now, it doesn't matter for us. Okay, we're not guessing the password here. We want to find out the correct username, and then we can move on and guess the correct password. That's why we use a fixed value for the password, which happens to be password. Okay. In another try loop here, we have, as you can see, we start supplying the values, and we monitor the response. If the response is wrong password, if wrong password found in the response, then we know that the username is valid, right? Based on the previous testing. So we print the statement valid username identified, accompanied with the username found through the word list. Or if we are given wrong username in the response text, it means that the username is wrong. So what do we do with this? What we do with that? We continue testing. We move to the next username for the invalid ones. Okay. Now when we run the script, so you go to the brute force. When we run the script using Python, okay, as you can see, we have identified two valid usernames, admin and Jose. So admin and Jose. All right, so now we have identified the valid usernames. It's time now to find the correct password. To find the correct password, we need a password word lists, okay? So we go to the other tab, and from here, let me show you how I found the password. Okay. So I used Hydra, but what was the command? Let me, guys, show you the exact command. Remember here that we are brute forcing a login form. So first, we provide the username, which is Jose, and then the password word list. In this case, I used RockU. Provide the target, lookup, and then here we have to specify that this is a login form, or HTTP form. So we use HTTP post form, and then the parameters. How to find these parameters? Let me tell you how. We go to Burp suite. Through the testing, we know that the username and the password parameters are this way. So we use them in the command here. So username, and we have the password. We give them user and pass as values. They will be supplied with the given username and the given password word list, the path of the page, and here wrong. Why wrong? Because it is the first word we see when we are actually presented with the output, whether the username is correct or not. So if the username was correct, we see wrong username, wrong password. If the username was not correct, we see wrong username. So wrong is always there. So we have to provide Hydra with the hints of how the application will respond to the request. So here we actually put wrong, -v for verbosity, and we execute. Once we execute this, we see we are going through a long list of passwords against the username Jose. Scrolling down, we can see after a long wait, we have the password for the user Jose, password 123. Once you find the password, proceed and log in. So Jose, and the password is password 123. And here we are redirected to another destination, files.lookup.thm. Remember to add this to the host file as well, as can be seen from here. So it's a simple file manager. And there are many files here. Among these files, we can see user, root. Most of these files are locked, except credentials. If you attempt to right-click credentials and click on open, you'll see that there is a username, think, and a password, no password. Now you might be tempted to go ahead and try this using SSH, but it's not going to work. So giving you a heads up that there is another username called think. Okay, what else to explore here? So we can go to get info. Sorry, not this one. You can go to question mark to have a look at the information about the software. And you can see the name is lfinder. It's a web file manager and the version. It's a web application at the end. And because it's a web application, it is, or it can be exploitable. So what we do now, we go to the command prompt here, the terminal, and we use search exploit. Now, in search exploit, we have 4 active exploits. One of these exploits, let's go back and see the version is 2.1.47. This exploit exactly matches the current condition of the web application. So here, PHP connector for versions before 2.1.48. The actual version here is 2.1.47, which works for us. We have this as well, PHP connector command injection. I think these two are the same, but the execution channel is different. So here you execute the script, you execute the exploit using a Python script, and here you can use Metasploit. This one won't work because it's for version 2.1.53, and this one is a file creation. It won't work for us. So we are left either with the first one or the other one. If you want a non-Metasploit path, you can go with the first one. If you want a Metasploit path, you can just use this one. So we open up Metasploit and we search for the actual exploit. So we use the command search -type exploit -name lfinder. We're looking for, we want to search the exploits in Metasploit and extract the ones that contain the name lfinder. So we have 4 ones. And the 4 exploits, among the 4 exploits, the one we were looking for is this. So we copy the name and we activate the exploit. Here we can see what are the required options. So we have our port is already set, which is 80. It matches the correct environment. And here we have target URL. It's also set to the correct path. Still we have our hosts to define and the lhost and lport if you are looking to change them. So what I did here, I changed our hosts to files lookup.thm. It's not lookup.thm, it is files lookup.thm because it is the domain that matches, or it's the domain that hosts the web application we are exploiting. If you use the IP address of the machine or if you use the main domain, it will not work because the application is not hosted there. It's hosted on the subdomain. So you have to provide the subdomain. Just provide the subdomain and exploit, and it will work. You will have the first session. It is an interpreter session, so I used shell to directly interact with the machine. Then I used a TTY to have a stable shell. Just as with any enumeration scenario, you would start first with the enumeration. So here I determining the current user, data, the current directory. We are in the directory of the web application, lfinder, hosted on public HTML. And then we extract the contents of the password file because we want to see the users active on the system. You can see we have data and we have think, which we encountered previously while enumerating the lfinder application. Okay, so we try to take a look at what the user think has in its home directory. So we have user.txt. The user.txt file is owned by root as a user and think as a group. So as data, we don't have access to this file. Also, we don't have access to this mysterious file named passwords. As data, you don't have access to any of these. So what you want to do, you want to escalate from data to user think as a first step. So how to do privilege escalation? This is a vast subject. One of the methods is to import linpiece and let linpiece find the correct privilege escalation path. But with this machine, you can just run this command to find out what are the binaries that have the SUID bit set. You see here among these binaries, most of these binaries are actually built in with the Linux system, except we have this weird binary here. Let's have a look here. Where is this? Scrolling down, we have this one, PWM. So PWM, according to Linux kernel archives, it's used for controlling LEDs, fans, or vibrators in cell phones. PWMs with a fixed purpose have no need implementing the Linux PWM API. So it's worth wondering why would such a binary has the SUID bit set. We investigate the binary further, and we can see that it is owned by root, and it has the SUID bit set for the owner and for the group. We try to run the binary, and we monitor the output. This is the output of the binary. First, the binary tries to run ID command. As you can see, running ID command to extract the username and user ID. Now, after POM runs the ID command, it gives you the ID it found. In my case, it found that I am the data, so the output was data. And then there is this output file, home data dot passwords not found. This file is not found in the home directory of the user data. Looks like the command here first probes the ID of the current user logged in, and then tries to open. It assumes that the current user has a file named passwords in its home directory. It tries to open it. If it doesn't find it, it's going to tell you that the passwords file is not found. Now, remember earlier that we find that this file exists under think user. So here in think home directory, this is the think user, and there is the file passwords. So if we can trick this binary, which happens to be PWM, if we can trick it to think that the ID of the user is think, it's going to open the passwords file for us. If we open the passwords file, we can then use this file to log into the user think. So how are we going to do this? We're going to create a fake binary for PWM to run. The fake binary will be will be named as ID. This file will run a fake ID command showing that the ID is think or belongs to the user think, not data. Let's see how this will work. So here I actually created the file under the temp directory. The first thing, as you can see, we have to specify the shebang. So that's what I did. At first glance, I actually named the file as PWM modified, but I changed this later. Never mind the name now. So next I added this to the file. See, echo, this echoes the parameters of the user think. How we got these from the passwords file earlier, etc passwords. And then we sent all of this to the new PWM modified. Change the permissions so that PWM modified can be executed. Now the next thing, if I want to execute my version of PWM, I have to change the environment variable. So I added the temp directory here to the environment variable, so it becomes first. Echo path, as you can see, temp directory now is the first directory in the chain of directories in the environment variables, in the path environment variable. And then I try to execute this, I still get data. So what I need to change here, I need to change the name of the binary I created from PWM modified into ID. Because, why? Because PWM first runs ID. Okay, if I name my binary as ID, it's going to execute my binary first. My binary will impersonate the user think, so that now PWM thinks, oh, this is the user think, I will be opening the passwords file. So here, let's see what happens. When you execute user sbin PWM, what happened here, as you can see, it's giving you a prompt that I'm running the ID command, and then it runs the ID command, and it found that we are the user think, and based on that, it executes the command here to list the contents of the passwords file found under the home directory of the user think. And indeed, there is a passwords file under the home directory of user think, and this is the content of this file. You copy the contents and you move on to copying. Just copy the contents or copy the passwords here into a new file and save it into a passwords file. So what you want to do here, you want to, let me show you. So I created a new file named Jose word list. Jose word list contains all the passwords we found here, okay? And then I used Hydra. So with Hydra, we defined username as think, the password word list we already have, Jose word list, and then here we are actually enumerating SSH. Lookup DHM port 22. Once we start the brute force process, we find the correct password. Once you find the correct password, you can now log in as think, and you are successfully escalated the privileges from data into think username. Now it's time to shift from think into root. The first thing you want to do is to run sudo -l to see what are the capabilities granted to the username think. You can see that the username think can run user bin look as all users, even as root. So we take a look at the binary look using GTFObins to see what are the abuse vectors we can use here. So as sudo, we can actually, if the binary is allowed to run as super user by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate or maintain privileged access. That's fine. If we can read sensitive files, we can still escalate the privileges, if you are able to extract maybe the private key of the root user, the private SSH key. That's why it's always recommended to disable SSH or root SSH logins. Because in such scenarios, you might be able to say, you might be saying that, oh, this escalation privilege does not allow direct access to the root user. It only allows access to file systems. So it's not that dangerous. It is dangerous if you are allowing SSH root logins. If you are allowing SSH root logins, there will be a private key for the root user. And if such weakness is found in the system, you'll be able to read that file, the private key. So what we do here, as you can see, sudo look, we use the exact same command from here. Instead of this variable, we define the path to the private key of the root user. And we have the file. Okay, now we move on to login as root. So we save this into a separate key file, IDRSA. We give it the correct permissions needed for the private key, which is 600. And then we try to log in as root using this command. So we define we supply the private key and then username at the machine, and we have access to the root. Once you have access to the root, you can then access the flag, the user flag, and the root flag.